my most important job for the day today. Um, I'm going to mute my mic and I'm going to turn off my camera, and you are going to have total control of the webinar.
Okay.
And then Jason and myself will monitor the guest, and we'll monitor the chat rooms and everything. And when we get to a break at the end, we'll just jump back in here with you and we'll answer any questions that have come in. So
Okay, terrific.
it's your show, sir.
All right. Well, thank you very much. So my name is Michael Camber. I'm actually the marketing manager at Kaeser Compressors. I've been here over 20 years. And I really, in learning a lot about, compressed air is used in a lot of industries, basically any kind of manufacturing, any kind of processing, industrial, non-industrial. And most of our business is in the manufacturing arena, but in the automotive, and most of what we sell, and I'm not going to be talking about product here, but most of what we do is sell larger rotary screw type compressors. So it's generally on the larger side of manufacturing and so forth. But the collision market is really kind of a favorite here because it, among the automotive service, tires and fleet and so forth, collision is most like a manufacturer, or as I like to call it, a remanufacturer. And the need for steady pressure, good flows, good quality air is just like a manufacturer of wood, metal, plastics, food, almost anything. So maybe a difference in size, but not always. But for that reason, I kind of cut my teeth many years ago on learning about the needs of paint, body, collision repair shops as a way of learning about compressed air systems. So I'm going to go through today. I had about 50 slides, and they were just getting a little too dense. So I cut it in half, and I'm going to talk today primarily about. Let's see if I can get my slides to move. But I'm going to talk primarily about the key design criteria, types of compressors, and sizing them, and then some tips for reliability and energy efficiency. So let's see, I actually should have tested this before, but I need to get my slides to move. Any tips here? I can see my.
Are you in PowerPoint presenter?
Yeah, no.
Okay.
So do I need, well, yes, I'm in the present mode in PowerPoint.
Okay.
But it's
you should be able to click on that presentation and advance them, or spacebar advance them.
Oh, there we go.
Hey.
Okay. So
my contribution for the day, Mike.
Thank you. Thank you. So as I said, I divvied this up into two parts. So today we'll talk about sort of basic design criteria, types of compressors, sizing, and then equally important are air quality issues, getting moisture and particulate and oily stuff out of the air, and then things about piping. So I thought I would save that for another time, and hopefully you'll like today's, and then you can invite me back. If so, invite me back and I'll talk about the next, talk about that stuff next time. So looking at some key design factors. First of all, want to emphasize the point that every component in a compressed air system plays a role in the air quality, pressure, flow, or CFM, and the energy efficiency of the system. Energy efficiency is going to matter more in some circumstances than others. Depends on how big the compressor is, what you pay for power, and how often you run it. So if you don't run it that much and you have a small compressor and you pay 3 cents a kilowatt, energy efficiency is not top of mind. But in some places, Hawaii, California, the Northeast, or if you have a big shop with a 15, 20, 25 horsepower, then it starts to make a difference. So we'll talk a little bit about that too. So moving on to some of the key design criteria, the classics. What pressure do you need? What's the minimum, and I'll emphasize, what's the minimum acceptable pressure? Because there's a penalty for putting too much pressure in your system. Flow, what do you need? That's cubic CFM, or cubic feet per minute. And that also related to flow, how often is the air needed? We'll talk a little bit about sizing, about that when we talk about sizing. And then air quality. what are you using the air for? How sensitive is your product or process for to water, dirt, dust, oils? Of course, in collision repair, we paint, body, and we know the need is high for good quality air, so we don't have to explore that. And there are different ways of getting there. So another criteria is space. Where are you going to put the compressor? Does your space allow for good access to get around the machine and service it, or lighting? So those are some aspects. Where are you going to put it? Related to that is the temperature of the space where you're going to, where you're going to site the machine. Heat kills compressors. It also affects air quality. So good ventilation is important. And keeping that compressor room temperature within limits. And then noise. Noise may or may not be a problem. It depends on where the compressor is related to people working or customers. So you have to consider, is noise going to be a problem for safety, morale, or customer comfort? If not, you've got some more flexibility on what type of equipment you get. So pressure. We measure pressure in PSI, pounds per square inch, gauge, or bar. That's typically what you see in Europe. But 1 bar, if you're ever looking at a machine and it says it's a 1 bar, it's 7 bar. Basically, it's 14.5 pounds per bar. So a 7 bar machine is going to be in that 90 to 100 pound range. And you won't see that much, except you might see it on a spec for a European machine. But most European manufacturers, like Kaeser, we present our product in English terms, or imperial, I think is the right word. So the other thing to remember about pressure is pressure does not determine the size of the compressor. So you can have a 5 horsepower compressor that makes 125 pounds, or you can have a 500 horsepower compressor making 125 pounds. So the pressure is not related to the size of the machine. Also, you want to, when you're thinking about your system, think about the different tools and what pressures they need, and operate at the lowest possible pressure, because this saves you air and energy. A rule of thumb is, once you get to the 100 PSI range, every couple of pounds that you crank the compressor up is another % of energy it takes to get there. So, some compressors, off the shelf, the standard is 145, cuts into 145. But if you only need 90 at your tools, that is energy that could be wasted. There may be other reasons for it that you need it, but not always. So if you've got lifts that need that pressure, that's one thing. If you don't, you want to operate at the lowest possible pressure, because tools need flow, not extra pressure, to get the job done. All right. This is kind of a little bit of a non sequitur, but I wanted to make the point that while we're talking about pressure, that there are a number of sources of pressure drop in your system that can starve your, or seemingly starve your tools for air, where you just feel like, I'm not getting enough pressure, and you may want to crank the machine up. So there are different components in a system. You may not have all of these, but you typically will have a particulate filter, a refrigerated dryer, and a coalescing filter. Those are going to have pressure drop when they are when they're new. When the filter elements are new, that pressure drop may be a couple pounds. As the filter gets filled up with debris, that pressure drop will increase. Piping is another source of pressure drop. I'm going to talk about piping, pipe sizing in part 2. So these terms, flow, volume, and capacity, are all interchangeable. They all refer to the CFM that the compressor delivers. And the flow does determine the size of the compressor. So a rule of thumb, and it depends on the type of compressor, and we'll get into that in some detail, but if you estimate 4 CFM per horsepower on a rotary and maybe 3.5 on a piston, that tells you the size, more or less the size of the machine. Or when you know the horsepower of the machine, which is more common, you can make an educated guess on the flow of that machine. So a 10 horsepower rotary screw compressor, more or less 40 CFM. Some are going to be a little more, some are going to be a little less. And the amount of flow that's used really is determined by the size of the orifice in the tool, combined with what pressure you are operating at. So the same tool, if you are pushing 10 CFM, but you're operating at 145 pounds, you are putting more air through there than if you're operating 10 CFM at 100 pounds. And unless you need the higher pressure, you're wasting the power to create that pressure and robbing other tools of that air. Another important point is that most air is wasted, easily 30, 40, 50%. Okay, it can be through leaks in a variety of places. Hoses in collision shops, hoses are notorious, and the fittings for hoses. If you can hear it when you, at the end of the day, before the, when people stop working and running tools and you can hear it, that's money. If you cannot hear it and you have a lot of little leaks that you can't hear, that could still be big money. Okay. Great reason to just turn the compressors off at night, because they will happily come on and off all night feeding leaks if you don't just turn them off. All right. Now, of course, fixing your leaks is ultimately the goal. But even a well-maintained system, a fairly tight system, might have 10% leaks, 15% leaks. Leaks come back over time. So leaks is something we can talk about a little bit when we talk about piping. But just keep in mind that leaks are a user of air. Another user of air is what we call artificial demand, and that means running tools at a higher pressure than they need. So you have a DA sander and it needs 90 and you're running it at 145 without regulating it down. That's wasting air, which again robs other tools of the air that you might need. But it also, even if you have the capacity in the compressor, just means you're wasting power. Okay, so leaks also leak more at higher pressure, and so you want to set the compressor as low as possible without getting complaints from the people who are operating those tools. So we do this in big plants. We tell them, go to your compressor and adjust go to the controller or the pressure switch and just drop it maybe a pound a week. See what happens. Keep doing it until somebody squawks and says, hey, I'm not getting the pressure I need. Then you can move it back up. But we've seen people reduce their pressure 20, 30 pounds. So just be aware of that. And then if you need the high pressure in some places, like a lift, but you don't at other workstations, use regulators. Regulate that pressure down at the point of use, and that's very commonly done. So this will save you air that you need for production, as well as the energy to make it. So the last item in terms of wasted air is what we call inappropriate uses. Most often in your environment, this is going to be people who have a nozzle on the end of a hose and they just use it to dust themselves off at the end of the day, or to clean the floor or their workbench. A broom, a lot less expensive, because people don't understand how much air they're using when they do that. Or people who tape that little nozzle open and then clamp it to a workstation to blow air on them. Buy them a fan. Far less money. So brooms, shop vacs, and fans are way less than using compressed air for that kind of thing. So now we'll talk about types of compressors. And there are three types that are most common in paint and body world. Piston or reciprocating, same thing, rotary screw, and rotary vane. And I want to emphasize here that none is inherently better than the other. Each has pros and cons. Within each type, there's a variety of brands, and they will vary in quality and reliability and energy efficiency and so forth. But in terms of, I'm not going to sit here and say a rotary screw is inherently better for the collision market than a piston or a vane, because it's not true. It really depends on, well, one, your budget, what your flow and your pressure needs are, how much you're using the air, what size of the shop is, where you're going to put that machine, the air quality needed, whether noise is a concern, things like that. Because if noise isn't a concern, the benefits of a vane or a screw in terms of low noise may not matter. If you don't need the other features of it, the noise may not be the thing that makes it worth spending the extra money. Um, and these are things to consider. All right, so just basics about the designs. The typical shop compressor, piston, or recip is usually a single acting two-stage design. So it basically air gets pumped up to one pressure at the first stage and then goes over to the second stage and gets pumped up a little bit more. And they will usually top out about 175. So sometimes people will get them maybe they'll have them set to turn on at 125 and turn off at 145 or 150 or 145 to 175. Those are common factory settings, but you can adjust those. A typical piston is, a good one, is going to deliver 3.5 CFM per horsepower. 4 is rare. 3 is going to be for the lower grade um, light duty machines. So good quality from reputable brand. You should get about 3.5. And there are ways to verify how much air you're getting, because one thing about a piston is that it has rings and they wear just like in a car. And over time, if they wear enough, you get blow by, which means you'll get less air pumped out. But there's a simple test, we call it a pump up test, where you can see how much air am I actually making or getting from my piston compressor. Okay. It has an open lubrication system, which means it's got a little crankcase. You add oil every now and then. You just every now and then keep adding oil. There's an oil sight glass, and you just keep an eye on it and add it. Very low maintenance. There's, you see inlet filters there. Very simple, not a lot to it. Again, good ones can last many, many years. The one thing to keep in mind is the duty cycle. They typically are not designed to run nonstop. They're designed depending on, again, there are different levels of design. Some may only tolerate maybe a 50 or 60% duty cycle. Most of the good brands, they're going to be in that 60 to 70% duty cycle. And what that means is you can reliably run them. They'll cut on and off, but you can reliably run them 60, 70% of the time without overheating them and burning them up. Okay, so they do operate a little warmer than the rotary types, or a lot warmer, and usually the what we call the approach temperature, and that's the difference between the room that where the air comes in, the ambient air, and the discharge is at least 100 degrees Fahrenheit. Okay, I've seen it. So a piston compressor, it's going to heat up that air and come out, and the operating temperature could be anywhere from 250 to even 400 degrees. 400 is a little on excessive side, and where that matters is in compressor life and air quality, because it's harder to get moisture out of very hot air. Okay, we'll talk about that um, a little bit more, certainly in part 2. Okay, so that approach temperature is that delta between the ambient temperature where the air comes in and when it leaves the compressor. Rotary vanes, these are typical single stage rotary compressors. They are going to make between 4 and 5 CFM. 5 for rotaries is very much on the high side. There are a few out there that can get there, but most of the time 4 to 4.5 is solid. Okay, so you can already see a difference in the flow per horsepower, and of course what you pay for is kilowatts, not horsepower, but horsepower is the sort of commonly understood reference point. But you can already see a difference in the flow and efficiency of a rotary type over the piston. So that is one advantage on the rotary side. Rotary vanes, they can start in very low pressures. Typically, you wouldn't see that 30 pounds or 50 pounds in a collision shop, but there are other applications for them in industry where they do need those low pressures. They typically top out at about 125. For most shop equipment, that is more than adequate. If you do need something higher, um, for like sometimes some of the lifts need a higher pressure, then you want to look at that. Okay. They do have a closed lubrication system, much like your car has a closed cooling circuit. So it's a thermostatically controlled oil or some sort of fluid that acts as a lubricant and a cooling fluid, and that goes through the chamber in the compression chamber, and then goes through a cooler and is cooled to a particular temperature, and that allows it to run flat out 100% duty cycle. So it can just go and go and go all day long if you need it to. Of course, it'll shut off if you don't, but if you need it, it can just go and go without overheating, unless it's in a really hot room. That's a different, situation. So the approach temperature, the delta between the inlet and the discharge, is only about 15 degrees. And again, there are some machines, again, depends on the manufacturing design, but some might be 10 to 12, some might be 15 to 20, but we commonly say, for comparison, 15 degrees Fahrenheit difference. So that means there's not much difference between the temperature of the air coming into the compressor and leaving the compressor, and that's an advantage when you want to remove moisture. Rotary screw compressors, a lot of similar to rotary vanes, different design of the pump itself, two intermeshed screws, rather than a single rotor with sliding vanes on the vane compressor. Similar outputs, again, individual manufacturers or one model might be a little more efficient than another, from maker to maker, but there are ways to look at that, and we'll talk about that later. The pressure range on these, higher upper end. So if you do need a higher pressure, you'll never need that 215 or anything near that in a collision shop, but rotary screw compressors, and I'm not talking specifically about ours, but rotary screw compressors typically top out above 200. The operating temperature is about 180 to 210. That's sort of the sweet spot, similar to the rotary vane. Closed lubrication, 100% duty cycle, similar approach temperature. Okay, so the rotary screw and rotary vane are similar in many regards. One gives you a little more flexibility on the top end of pressure. After that, it's really about looking at their cost and the cost to maintain them. That's one of the differences there. So what I've done here is just a little comparative chart. I lumped both rotary vane and rotary screw in together because they have so many similarities. And basically, when you look at it, there's no doubt about that. Rotary types cost a lot more than a piston or a recip. They also have higher service costs, no doubt about it. They have separators, they have inlet filters, they have oil filters, and so forth. Some have belts. So whereas a piston, typically there's a belt, a very inexpensive inlet filter, and you keep a little oil on hand. It's night and day. Okay. The trade-off is, one, the rotaries put out more air. It's just inherent in their design. Pressure, you can, for the pressures that you need in most shops that we're talking about here, all good. Duty cycle, the rotaries, they can run flat out. So if you got a period where you have high productivity and you have a lot of air being drawn, and you're not going to run into the problem of burning up a machine. Okay. Pistons, you got to pay attention to the sizing for the duty cycle. The approach temperature, I already talked about, significant difference there. and that helps when it comes to getting the moisture out. Noise. Pistons are louder, they vibrate more, but if you're if if you're not working or sitting next to them, that may not matter. So the added benefit of low noise on a rotary type, vane or screw, which are both more or less the same, that may not be worth money to you. Okay. Efficiency. As we already demonstrated by the output, rotaries have an advantage on the amount of air that they make and the kilowatts it takes to make them. So if you have a 5 horsepower machine and you run it every now and then and you don't pay a lot for power, you're not going to recoup that money by buying a more efficient machine. I mean, it could take you 20 years, but depending on how much flow you use, how much you pay for power, and how many hours you run the machine, it could. Okay, so that's something to think about. So if you're comparing compressors and you want to look at the efficiency, the electrical efficiency of the machines, for rotaries, vane and rotary screw, there is this thing called a Kaeser data sheet. And Kaeser is an industry trade group called the Compressed Air and Gas Institute, and it's a 100-year-old organization that has all kinds. It has a website, and I'm going to provide this the slide deck, and it has a live link to the Kaeser website. And they have a program for rotary compressor manufacturers to voluntarily provide accurate performance information, meaning at a certain pressure, how much air do I get out and how much power do I put in at 100% load. Okay. Unfortunately, this is not available at this time for piston compressors. But if you're comparing, if energy efficiency is important to you, you have a 20 horsepower, or 15 or a 25, or something bigger, and you pay a lot for power, you run the heck out of it, you may want to look at this. And you can get those data sheets. Every manufacturer that participates in this program is required to provide them. Usually they're on their website. The Kaeser site has links to them, and you can look at them and compare them, the bottom line. The thing about the bottom line is it's only comparing the two compressors based on running 100% load with no idle time. And the reality is that doesn't happen. It's just because you may run it 55% of the time one day and 62% the next day, or it varies widely. So your mileage may vary. Very much applies here, but at least it's a point of comparison. And then the last bullet I have here is it really doesn't help you if your system is oversized. So system design, meaning the sizing of the compressor for the load you put on it, makes a whole lot more difference in terms of the energy and pressure stability of your system than the individual efficiency of the compressor. Okay, that's a really important point. So you could spend the extra money to buy a machine that's more efficient than the other one, but if it's not the right size, you're not going to get that benefit. So a couple more things about sizing and for different types of compressors. So I mentioned before with recip compressors, if you run them too much, you get heat-related problems. I mentioned heat kills. So here are some causes and results. The compressor, if it's undersized for the demand and you don't allow it to shut off and cool down, then it's that can be a problem. Now that is somewhat rare. Most of the time, people have bigger, they have ample-sized machines. But if your shop has grown and you have an added compressed air capacity, you may have more tools operating, and you may run that compressor more, and you might exceed its duty cycle. So that's that scenario. If you've got more leaks, which do develop over time, they demand air. So what you may not have added tools and people, but you've added leaks, or they've developed. That's another source of running the machine more than it's designed for. If the tank underneath that piston compressor has water in it instead of air, it's not storing air, so it's going to run more. It's not going to be able to shut off and cool down, so it's going to build up heat, and you'll have more problems. And those problems include things like running hotter and vaporizing more of the crankcase oil. And I'm getting a big echo. Are you guys hearing that? Okay.
It's gone now. We're good.
Okay, good. So if the piston compressor runs too hot over, for time, you're going to get more oil carryover, which means more oil is going to leave the compressor and go into your filter, well, hopefully into your filters and dryers to remove them. But ultimately, if those aren't there, it could go into your tools and paint. But also, it results in lack of lubrication. So you've got to keep an eye on that oil in there. If it gets too hot, it can warp the cylinders, which can mean you get more blow by and less air produced, or valves can get stuck, and the pistons can seize. And actually, if that happens, it can also take out the motor with it if something seizes. Usually, the belts will take up that slack and prevent a pump motor combination failure. But it happens. But if it's a hot environment, that's bad for motors in itself. So even if the compressor is not running too much, but it's just a hot room, that can cause some of these problems, as well as motor issues. Okay, so heat isn't good for pistons. Not good for rotaries either, and we'll talk about that. So it's not a plug. It's just heat is not good for compressed air. Okay, so I'm going to talk about a common problem for rotary screw compressors, and that is oversizing them. So we do a lot of system assessments, from small systems to monster systems, and even big sophisticated shops and manufacturers have often have way more compressed air capacity than they need. So that if you've got one big compressor, that's a problem. Okay. Now it's not a problem for recips. You oversize a recip, hey, they just run cooler. They like stop and go, and that's fine. Okay. But rotaries like highway miles, and if they're meaning they want to, they will start and stop, and we have many of them that do it without complaint for a long time. But there are ramifications for service with a lot of stop and go, which if the machine is too big, it's basically going to pressurize the system. It'll then say, okay, I've made enough pressure, I'm going to shut off, and it may idle first and then shut off. But the more it does that, it's long-term not great. Okay, so having some excess capacity is fine. Obviously, you don't want to run up against your max all the time, because what if you grow? Okay, or you just have a period of peak demand. So you want to have some excess, 10, 15, 20, 25% is fine. But if you're 50% oversized, or 60% oversized, that's a problem. And these are things that can be measured. So there are ways to find out. So continuing on the oversizing. So basically, if you have oversized system, one, you've spent too much money on the compressors because you bought bigger than you need. You're also likely going to pay more for the parts when it's time to do the regular service. And you will likely have higher maintenance costs. Okay, and again, this is for the rotaries. The frequent cycling that I described, turning off and on, idling, going from load to idle, you've got more valves that are gonna open and close more. Inlet valve, combined control vent valves, or different things on a rotary screw, and that a piston doesn't have. And those things, if you, just like any mechanical equipment, if you over operate them over time, they may wear. Too many starts can wear out a motor. Whenever you load and unload a rotary screw, you create what's called an axial thrust on the bearings. It's designed to take it, but if it's constant because it's oversized, it's just you're gonna need to replace the bearings. That is not a normal thing you do on a rotary screw air end, is replace bearings. It's not a maintenance. It's not a preventive maintenance thing. That's a problem call. Okay, and if it runs too cool because it's not running enough, moisture will build up in the oil system. This is a very common problem, and if moisture builds up in that coolant / lubrication system, lubricants, bearings aren't lubricated by water, so it's going to compromise lubrication, and you can get rust, and this can happen in a piston as well, but and not as likely. But you can get moisture buildup in the separator tank and in the air end and rust out the bearings, and then that's a very expensive fix. Okay, so these are some things to think about when you're trying to size your equipment, that you don't, buy a big machine now because you plan to grow. Okay, so it could compromise your lifespan, and the starting, stopping, and idling does waste energy. Okay, so this is going to be true for more or less true equally for rotary vane and rotary screw, because they both the vane doesn't have the thrust bearings, okay, because it operates a little differently, but the rotary screw has those thrust bearings. But still, the oil mixing or water mixing in the oil applies to both. Okay, so you can have some of the same, and the loading and unloading and so forth, very similar between the rotary vane and the rotary screw. Okay, so we're going to do a little quick exercise, a little scenario on sizing. Okay, now this is very simplified, but in this scenario, we've got 8 techs, each with a tool, and magically every tool uses 10 CFM at 90 pounds. So what size compressor would you pick? Okay, so let's use that rule of thumb of 4 CFM per horsepower, and so all right, what size compressor? You've got eight people, 10 CFM each, divide by 4, and we're going to assume no leaks. Okay, a big assumption here, but we're going to assume no leaks. So, where does that put us? That puts us, again, for sake of argument, in the 20 horsepower range. Okay, that's assuming everyone's using air simultaneously, steadily, which doesn't happen. In reality, people pick up tools, they operate them for a few minutes, they put them down, and someone else is doing the same thing. The idea that they're all going to be running simultaneously, again, statistically unlikely. So you can approach that a couple ways. You can split the load and say, you know what, instead of 120 horsepower making 80 CFM, I'm going to get 2 10s. So, we found that most of the time, one of those units is going to carry the load, and the other one comes on and off and trims, and then you can set the timer so that they swap. One's base load one day or 1 week, and then next week they swap roles. So you even the load hours. Okay, so that does a couple things for you. It one, it helps the machines run more highly loaded and reduces idle time, and so it saves energy. Okay, and it reduces some of those issues we talked about with moisture buildup and so forth. Okay, but it also gives you backup, because even worst case, if one of the 2 units is down, you still have some air. All right, and you may have most of the air that you need. Okay, so in the second scenario, let's assume that you have 50% utilization rate. So instead of 80 CFM, you have 40. Well, you could hit that with cover that with 1 10 horsepower, or split it between 2 5s. Buying 2 5s more expensive than buying a 10, no doubt about it. But you have that backup, and you have added energy efficiency. So if energy doesn't make a difference in the bottom line, maybe not important. The backup, though, what does it cost to be down for, a day? That is definitely something to think about. Okay, so now we'll make this a little more complex and say, now we're going to assume the 50% utilization, 40 CFM, and 20% leak load. So that's 20% of the total flow, which was 80. So 20, so basically 40 CFM plus 16 CFM, 56 CFM. So how would I, okay, so 210s, that'll work. 115 typically would also work. It's about 60 CFM. Or you can off-size them. You don't have to have the same size. You can have a 10 and a 5, or a 10 and a 7.5, or two, or two 7.5s. So here's where it becomes it's science, but it's still art, it's also art. So it gives you different options, and you need to have some knowledge about what the system is doing in terms of leaks and utilization of tools, but a little bit of information gathering, and then comparing the cost of buying the different size units, or combinations of units, and then thinking about the value of backup can help you make a decision when you're buying a system. Okay, hopefully I didn't make that too complex. All right, so sort of as I alluded to, you don't want to assume that everyone's using their tools all at the same time. So you have to, if you're trying to figure out what size you need, you want to look at the flow requirements of the tools. You want to multiply that by the number of people using those tools, but you've got to estimate the time they're operating the tools. There are some guides out there based on observation, but it may be something where you need to actually spend some time, on the floor with a stopwatch and just observe. But there are, if you, I have seen guides out there for, generally speaking, how much time people are operating certain types of hand tools. Okay. So here, the second point is, don't go big just because you got a great deal on eBay. Very tempting, and you can get great deals on used machines, but you don't want to just because you got a great deal on it and you got a 20 for the price of a new 5, that doesn't make it a good decision for your operation. Okay, so you want to keep that in mind. So splitting the load, we're big proponents of splitting the load because it extends the life of the machines. You've got the longer service intervals, it saves you energy, you have the backup, and ultimately you have less downtime, not only for the compressors, but less downtime in the shop waiting for air. Okay. And then consider a variable speed drive. Basically, every rotary compressor maker has them, and they cost more to buy, but depending on the size of your system, and again, how many hours you run it, and the cost of power, they can be very good investments. And you don't need to necessarily get two. You can get one fixed speed machine and one variable speed. And that's something that any good compressor, pro can help you figure out. Okay. So I'm going to talk a little bit about receiver tanks. Okay. So this is something I'm also going to, they have a dual role. They affect sort of the compressor flow pressure side of things, and they also affect the air quality side. But so tanks, both for rotaries and pistons, do the same things. They reduce the compressor cycling, i.e. reducing it turning on and off. They can extend the cool down time for pistons, and they can concentrate the run times for screw compressors so they're not cycling on and off as frequently. That helps with reliability and energy efficiency. Okay. And it also can store air for short, high demand events, which is good for your productivity. So if every now and then you've got there's something that goes on in your shop where you do have extra people operating tools, that tank can help smooth that curve, and can help or give you that buffer that you need with it, so that you don't lose pressure at any of those tools. It's also the first stage of air-liquid separation, and which helps reduce the load on dryers and filters downstream. So that's an air quality thing. We'll talk more about that in part 2. So rules of thumb, with tanks, bigger is better. You don't want to go crazy. We typically say 2 to 4 gallons per CFM. So, if you have a 40-gallon a 10 horsepower making 40 CFM, 120 gallon, 200 gallon tank is great. Okay. You want to think about where you put them because you don't want them to get hot. They don't generate heat, but if they're in the sun, they can warm up. Or if they're in a boiler room, or they're in a room that is the compressor room and the compressor's blowing hot air on it and there's not good ventilation, that's a problem. At the same time, you don't want them to freeze, but you want them to stay pretty cool. Also, because this is the first place where you're going to separate a lot of liquid, you want to have a good automatic drain. A few $100s, but an automatic drain. We recommend what we call a demand drain, not a timer drain, because a timer drain doesn't know if there's liquid in it or not that needs to be drained out, but a demand drain does. It basically either by a sensor or by a float, it only operates when there's liquid to be removed. Okay, so that is good for your air quality, but it is also really good to make sure that your tank stays dry or your tank has volume for air, which helps the compressor do its job. All right, and all tanks everywhere, you got to have a proper gauge and properly sized safety relief valve required by law. It's anytime you have a pressure vessel like that. Just got to make a plug for safety. Okay, this is one of those things I just kind of threw in here because the drying guns, different people have different terms for them, that are often used for shops that have waterborne paints. These use a lot of air. Okay, so these can, a stand with 2 or 4 of these things could keep a decent sized compressor going all by themselves. So because this is an intermittent use where sometimes you need a lot of air for flashing paint, but sometimes you don't, that is a good reason to have the 2 compressors to split the load. Okay, their operating pressure is typically pretty low, so you want to regulate that pressure down so you don't waste the air. And you want to and a lot of these things also have rings or bezels that you can turn to adjust how much flow. Usually they don't tell you how much flow they're, I don't think they have they don't have settings, but I've seen some that, use 7 CFM, and I've seen some that'll, and maybe the same ones will go all the way up to into the 20s. So you want to find that sweet spot where it is helping you flash and dry the paint, but not using too much air. Okay, so use them sparingly. And if you've got a lot of these things, you really want to think about alternatives. So there are other, in some booths, or there are blower systems and other kinds of drying systems. So if you have a ton of these things, that's using a lot of air. Okay, so I just wanted to make that point. All right, so tips for reliability: where you put the compressor, well, let me back up. So the type and the size and the location of the compressor affect your pressure stability. Okay, so what pressure setting you use and the flow it makes, will affect how stable your pressure is. It also affects your air quality, and the service costs we talked about at some length, and the equipment longevity, which is directly related to that. So, if it's in a hot environment, that's going to drive your costs up. If it's oversized on a rotary, it's going to drive your costs up. If it's undersized on a piston, it can, wear it out faster. So you've got to keep those things in mind. Maintaining them is critical. So again, the maintenance on a piston is very low, and a lot of times people just, they just let them go until something happens. But I would say you want to keep your eye on them. Rotary compressors typically have reminders, and they have control panels with indicator lights. That'll tell you, but you need to pay attention to them. Okay, so certainly it costs more money to maintain, but that'll keep them going longer, and it's worth it. And then again, you want to maintaining them will also keep especially on the rotary side, will keep the internal pressure drop of the compressor low. So the separators, oil filters, those can create pressure drops. So if you're not maintaining those, they get clogged up too much, and you'll have internal pressure drop, and the machine is fighting against that and using power to do it. Okay. Yeah, location. I've kind of made some of these points already. You definitely want to leave room for proper service, and you want to have a lit room so you can see what's going on when you go to service the machines. And you want to make sure that room is ventilated. You want to clean the coolers off the machine if it's a high dust environment. Also, while you're at it, if a refrige dryer, the condensers that look like the cooler on the compressor also can get dusty. That affects the dryers. We'll talk more about that part two. Yeah, I recommend hanging a thermometer in the room just to see, so you know if you're operating within the spec of the compressors. Most rotaries don't want to see room temp above 110, 115. That's kind of their upper end. So good to have a thermometer in there, and then if you may be able to correlate any issues you're having, whether it's with the compressor or with drawing of air with the room temp. Okay, so a cheap, $5 thermometer is worth putting on the wall in the compressor room. Going back to energy for a minute, we do recommend splitting the load, and again, operate at that lowest pressure possible. You want to find and fix your leaks. Find the worst ones first. It'll make a big difference. The ones you can hear. There are ultrasonic leak detectors. Someone can, you can often borrow them, rent them, or have someone come in and do it. But go after the ones you can hear. If you've got, you want to change your filters for your compressors and your inline filters for your air treatment, you want to do that on a schedule, so that you don't have the pressure drop that robs you of steals energy and robs you of air. Zero loss automatic drains I mentioned. Again, turn the compressors off at night or whenever they're not needed. And then if you're trying to get energy efficient, and if that's going to make a difference on your bottom line, use those KGI data sheets when you're making a choice. Okay, so next time I want to talk about air quality, and we'll talk about dryers and filters and drains and piping, including sizing dryers, which is very important. All right, so these are some additional resources. These are live links that you'll have when we post the slides. Okay, all right. Thank you for your attention. I realize I bumped up against my allotted time, but I'm not going anywhere if you have questions.
Yeah. Where are we going to go, Mike? We're all, it literally is a captured audience in a lot of ways. A couple of questions to come in, so we'll just divide them out as we go here. So what are the pros and cons of oil versus oil-free compressors in a body shop environment?
Oh, okay. Yeah, oil-free compressors, not that common in general. They typically cost more. And I'm thinking, again, my bias is on the rotary screw side. So there are oil-free recips. But in both cases, they're going to run hotter. They typically are more expensive to buy. Rotary oil-free rotary screws, sometimes the labor rate for the service is higher because sometimes those are they're specialized technicians. Usually they're going to be two-stage rotary screw machines because an oil-free, one of the things the oil does in a rotary, whether it's a vane or a rotary screw, is it acts as the rings. It acts as the thing that seals the gap between the rotors and the housing. So it helps the compression. If you don't have that, you need to go two-stage in order to get to even, 125 pounds. Okay. And you really, as far as the air quality, you still have to remove moisture. You still have to remove particulate. So you still need the air treatment equipment that you would need anyway. Um, the um, an oil-free machine is still going to suck in and push through it anything that's in the air. So any kind of aerosols, someone sprays WD-40, it's going in the compressor and it's coming out through the compressor. So in a so you have to have a coalescing filter anyway, and that's going to capture it. A rotary screw, a compressor vane, or rotary screw type, um, may have 3, 4, 5 parts per million of oil that it loses. Pistons, considerably more, but again, a coalescing filter is going to trap that stuff before it goes into your paint. So we really don't think that oil-free is necessary. I have not run into it. I'm sure they're out there, but I don't think the cost benefit makes sense.
Yeah, especially if you're gonna go oil free for that, but then you're still gonna have to filter all the air. So you're still
Yes,
putting all that equipment in.
you still got to, you still got to dry it, and they operate hotter.
Yeah.
So that's one of the things.
That hot operation is one of those things you just don't think about. I
Yep.
remember growing up as a kid, our compressor, we had an old piston compressor. Thing was huge, and it was like a monster when I was little. But it was always outside, and then just when you think about the heat that puts off, and then what that does to your air is that condenses some things. So
yeah.
here's a great. Oh, I'm sorry.
Okay. Oh, I was going to say, and you mentioned being outside. Putting compressors outside is okay. You got to think about the climate. You don't want them to freeze. There are ways to protect them against freezing because they do have the oil, and it could get too thick if it gets too cold. But you can deal with that. But you will always want to put a roof over them.
Yeah.
You just want to shade them, protect them from the rain. But if that's what it takes to get rid of the noise, putting them out back. And especially in dry environments like California and, Arizona, people do it all the time.
Yeah. Well, I guess this next question, a nice segue. But because it's what I have 2 5 horsepowers in Collision Hub, and I don't have to worry. They're right in the middle. If you watch a Collision Hub videos, the compressors are sitting right in the middle of the studio. That's how quiet they are. They're we didn't have to hide them. We didn't have to build a special room. We just plopped them right out there for everyone to see. But the question, Mike, is what's the percentage or the purchasing difference between 2 5 horsepower units versus buying 110?
Okay. So I would say, well, first of all, what you can do is you can buy 2 5s and then buy 1 dryer that's sized for both combined. Okay. Or you could buy 2 5s that have integrated dryers. Again, you got a lot of options, and then you get 1 tank and you pipe it all into one system, 1 filter for the whole thing. So I would say just on the compressor side of it, 2 5s against 110, that might be 30-40%. I mean, I'd have to have someone price one, actually price it out. But yeah, I mean, it's not an insignificant number. But again, you have to look at the benefits of the energy efficiency, the backup capability, things like that. So
Yeah, and I'll speak to. I've got so for me, my compressor service, the guy is local. Actually, there's a funny story. Did I tell you the funny story of the local Kaeser service guy that comes out, Mike? He was my prom date, my high
Yes,
school
I
prom
love that.
date. Yeah, and he
I
shows up
love
at my
that.
shop, and I'm like, "Why are you here?" But anyway,
Well, the scary part was the second time he showed up, he had his lime green tux.
that I will one day bring out those prom videos. That was when Garth Brooks was huge, and I am an Arkansas kid. So,
Yeah.
But anyway, I digress. The service comes out of Memphis, technically 2 hours, and they dispatch it here. But the hardest part for service for me is I want to be here when they're here, and so I've actually had one of my compressors down for about a week. And my other one combined with my reserve tank, and then I piped in a loop, which holds a lot of air. I'm still functional while I'm waiting to schedule. The guy keeps calling me, going, "When are you going to actually be able to talk to me when I come see you?" And so that's the other thing that I love about the 2 5 setup. One, they're sharing a load, so I'm lowering cycles on each of them because of that. But then when I did have a problem, I'm still functional. I mean, I'm not like, oh my God, my compressor's down. It's one thing when the paint booth goes down because it stops paint
Yeah.
production, but at
Right.
least the body's still working. But when my compressor goes down, nothing's getting done in the shop. So I
Yeah.
do like having the 2 units. That's been an unintended blessing, I guess.
Yeah.
I'll say.
So the other other thing I'll say about the cost of 2 units versus 1 is if you're just looking at the compressors, yeah, it adds it definitely adds some dollars. If you're looking at it in terms of the entire installation, so if it's a new system completely and you're talking about piping and the dryers, filters, and installation, then that percentage shrinks quite a bit.
Yeah. So, I mean, just to clarify that, Randy, just for you on your question, it is more to buy. It costs a little bit more, not a
Absolutely.
lot, but it did cost a little bit more. But the long term of that maintenance, lower cost, lower electricity, and then this emergency situation that's kind of happened here recently. Because I don't know. I didn't say it and I meant to at the start, Michael, but I was watching kind of on Instagram and I forget sometimes because I just think of you guys as collision shop people, that you have a lot of commercial applications, including hospitals. So a lot of compressor equipment and some other, some hospital work. So I'm trying not to override my service technician because I know that y'all are busy doing more important things right now than worried about Collision Hub's air. But but Randy, I would tell you that splitting it that way has been a huge bonus for me when I didn't expect it. So, Jason, you got anything else? Compressors?
No, nothing for me.
Yeah.
Okay.
So you will be back, Michael, for part 2.
Okay.
Because
Hopefully that
this-
was worthwhile. And I would certainly like to hear any feedback if there's anything I didn't cover in enough depth, or if I got, if I can, started rambling. Yeah, let me know.
Yeah, anybody, and if you have any additional Kaeser questions or anything that we haven't covered, he is coming back for part 2 to dive a little deeper because air is one of those things that we take for granted a lot in the body shop, and I think a lot of times we don't know the problems it can create if it's not done right, and the problems it can solve when it is done right. And besides having a good unit, piping is huge. So I'm glad you start piping because I still get questions. In fact, I was trying to find it while you were talking, but there was one the other day, still people asking about PVC pipe in collision repair. And I'm like,
yeah. Hey, it's not just collision repair. I've seen it in manufacturing. It's not that common, but it's out there.
yeah, I'm surprised, but hopefully we'll cover all of that. So
yes.
That, and I should have that in front of me because I put part 2 of yours on the calendar, but I'll have to, I think it's in another week, not next week, but the week after that, I put you on the calendar for part 2.
All right.
So we'll see you back then. I have a question. Michael, if you could just give your contact information out because I got some questions.
Oh, yes. I'm sorry. I should have put that right on here. So my email is very easy. It's michael.camber, and I'll go back to the, MICHAEL .CAMBER, good automotive term, at Kaeser.com. Kaeser. So yeah, send me an email if you have any additional question. Happy to help you there. I can give you my phone. Also, my direct line is 540-684-9489. And if you want to pump that out there, that's fine too.
Perfect. Yeah. So I put your email address and your phone number in the chat group.
Okay, great.
So that it's there for everybody. Awesome. And then we're back tomorrow. Jason, you're the lone anchor presenter tomorrow. No pressure.
Got her handled. Yeah. So tomorrow we're going to follow up the previous presentation that we had on ADAS systems, identifying ADAS systems, really building into your repair plan. And tomorrow we're going to talk about how to identify when calibration is required. So we'll talk a little bit about why calibration is important and aiming of ADAS systems, and then we'll jump into how to identify and how to determine when calibration is required, so you can again build that in your repair plan.
Perfect. A big important topic. It's hard enough to identify it that it's hard to determine, well, what do I do with it now that I've repaired the car? So big day tomorrow. Michael, thank you for joining us. And
Oh,
I
you're
will
very
have
welcome.
this up for replay for those that want to go back through his slides and take more notes. I'll have it up for replay probably in then about 2 hours on YouTube.
Terrific.
Thank you, sir.
All right.
You'll have a great day.
All right.